In the previous video, we have considered the indexing of documents encoded as plain text. However, in many use cases, documents are actually semi-structured, for example as web pages. In this case, the content is mixed up with some form of markup, for example HTML markup. The structure from the HTML markup might be useful. For example, imagine a query matches a web page in the main content, and it matches another web page also with respect to content enclosed within the h1 tags, maybe the bold tags, the b tags, or even in the title of the page. Well, the second web page might be a better match for our query because of the importance implied by the semantics of these HTML tags that make up the structure of the page. So, how do we maintain this field information into an index? There are two main approaches. Well, there is also a third one actually that I will explain in the next slide. The first approach is quite simple. Build separate inverted lists for each field. So one for title, one for h1, and so on. This is somewhat like building one index per field. Then, finding a word in any field means handling all the inverted lists, that is, one for each field. Another approach is to store the field information into each word's posting. To do this, we would have to allocate one or more bits at the end of a posting to represent the field. For example, if we only have two fields, we can then get away with 1 bit. If we have 3 fields, then we need 2 bits, and so on. The problem with this approach is that if we have many fields, then we will need many bits to represent the fields. This means our index will grow substantially in size, hindering the efficiency of the search engine. Another disadvantage common to both approaches is that they are unable to distinguish whether two words appear in close proximity of two fields within the same name. A solution that addresses the disadvantages of the previous methods is the use of extents. An extent is a contiguous region in a document. The idea is to represent an extent using word positions. Then, for each field type, we would have the inverted list recording all the extents for that field. This boils down to recording the start and finish of a field.